Hello and welcome to Algebra, Unit 3, Concept 1, Lesson 3. You will notice that there are no notes accompanying this and that it is scheduled to last multiple days. So your objective today is that scholars will reason about the properties of rational and irrational numbers. So, your instructions today are you're going to look at each statement and try it out with different numbers. Then you're going to make a conjecture. Decide whether you think each statement is always, sometimes, or never true. If it is always true, you need to explain why on the slide. If it is sometimes true, you're going to give me an example when it is true and an example for when it is false. And if it is never true, you're again going to explain why on the slide. You may work with other classmates on this, but each of you are responsible for submitting your own assignment. So these are your instructions, and this entire video is simply the instructions for this assignment. You're going to look at each of the statements. Each statement's on a separate slide. You're going to try it out with different numbers. Then you're going to make a conjecture. Decide whether you think each statement is always, sometimes, or never true. If you think it's always true, you're going to explain why. Make sure you give examples. If it is sometimes true, you're going to give me an example when it is true and an example for when it is false. If it is never true, explain why with examples. So, consider some of these numbers when you're thinking about each of the statements. So I just want to give you some numbers to consider so that you can try these out. Some of these numbers and try them out and decide whether you think it's always, sometimes, or never true. Let's look at these. I want you to consider using some of these numbers when you're thinking about the statements. So I've asked you to try it out with different numbers. So I gave you some different numbers and expressions to use that I want you to consider as you're doing this. So the first statement is the sum of a rational number and an irrational number is irrational. You're going to you can put your notes here. You could do this on paper and then just upload images, however you want to do it. At the end, though, you do have to tell me whether it is always, sometimes, or never true. That is the key, and you have to have some explanations for why. So you have several slides that look like this. At the top, you have to tell me always, sometimes, or never true. And here is your statement. This statement says, the sum of a rational number and an irrational number is irrational. You're going to take some time and try adding some different rational and irrational numbers. Put some here where they are true. And if they're false, you're going to list the examples here. Try out different ones and then make a conjecture whether you think this is always, sometimes, or never true. You can do this on paper and simply upload pictures, or you can write on it however you want. But pictures are an option. You may work together with your classmates, but each of you are responsible for turning in your own copy of these slides. There are several statements. The circumference of a circle is irrational. We have another one. The circumference of a circle is irrational. Is it always, sometimes, or never true? The diagonal of a square is irrational. The diagonal of a square is irrational. Is it always, sometimes, or never true? Lots of different, I believe there's 6 different statements that you're going to do. Sum of 2 rational numbers. The sum of 2 rational numbers is rational. Always, sometimes, or never true. Product of a rational number and an irrational number. The product, now we're multiplying, of a rational number and an irrational number is irrational. Sum of 2 irrational. The sum of 2 irrational numbers is irrational. Numbers. Product of 2 rational numbers. The product of 2 rational numbers is irrational. Product of 2 irrational numbers. Student. The product, again, product means multiplication, of two irrational numbers is irrational. Okay, so after you do all those, if you have time, there is extra credit. These are some different statements. You're going to do the exact same thing. Look at the statement, try it out with different numbers. And then tell me whether it's always, sometimes, or never true, just like you did for the previous ones. But these ones take a little bit more thought. Okay, so once you're done with those, if you finish them before we are done with this week, you're going to look at this extra credit. And you're going to consider these different statements. You're following the same thing. You're going to look at each statement and try it with different numbers. Then you're going to decide whether it is always true, sometimes true, or never true. Again, always true, explain with examples. Sometimes true. Example for when it's true, and an example for when it's false. And if it's never true, again, you're explaining with examples, guys. Don't just give me words. I want examples. Okay? So let's try this. An expression that contains both the square root of 6 and pi is irrational. Is it always true, sometimes true, or never true? And remember that you must give me some reasoning. So these look a little bit different. So an expression that contains the square root of 6 and pi is irrational. You're going to need to look at some of those. Same thing. Between two rational numbers, there is an irrational number. Is that always, sometimes, or never true? And explain why. Even between two rational numbers, there's an irrational number. Between two irrational numbers, there is an irrational number. To do. Between two irrational numbers, there is an irrational number. If the area of a circle is rational, the circumference is rational. So each of these is always, sometimes, or never true. And you're going to explain class period. If the area of a circle is rational, the circumference is rational. Make sure that you remember your formulas. Formula for a circle, for the area of a circle. Area equals pi times the radius squared. Circumference is pi times the diameter. Why you think so. Finally, if the circumference of a circle is rational, then the area is rational. Think about what you know about these formulas and how they work. Try it out with different numbers and play with it. This should take you, I know, more than... If the circumference of a circle is rational, then the area is rational. Look back at those formulas. This is the last one. Please take your time. You guys have 2 days to work on this assignment. I hope you enjoy. Once again, you may work with your classmates, but each of you must turn in your own assignment. Have fun.